Hi friends, welcome to the second video of this Java 8 feature series. In this video, we are going to we are going to discuss the second most important feature, and which is my favorite one, that is Lambda Expressions. So in simple definition, the Lambda expression is used to remove the boilerplate code, means the code which we unnecessarily put, means due to maintain the syntax and something that is known as the boilerplate code, right? So Lambda expressions are used to remove the boilerplate code. So okay, let me explain with example. Consider the interface known as student, which will have one method, and this takes one argument, and there is one class which is going to implement the class with name student impl, which implements the student interface. So this class must implement the show info method, right? So I'm just putting the out statement here, name plus name. Okay, so to call this method, what I need the object of student. We can means student s is equal to, we can't do new student because student is an interface. So we can create, but we can create the reference variable of interface. So here we are creating the object of student equal. So to call the method, I'm just going to call the s.showInfo. I'm passing my name. So this will just give the output as name and Shital. Okay, but if you look at the code, then you will get to know that we are creating the whole new class to just implement the single interface, and the interface which has the single method, that is single abstract method. So rather than creating the whole new class, what we can do, we can create the anonymous inner class, right? That is student s is equal to new student, and here I'm going to write out name. So this is known as the anonymous inner class. So this is also going to give me the same result. Okay, so here comes the lambda expression. Before, okay, here comes the lambda expression. So what Java 8 says, if you have the functional interface, that is the interface which has the single abstract method is known as the functional interface. So student interface have the single abstract method, so student interface is called as the functional interface. So Java 8 says that if you have the functional interface, then don't write any class to implement that interface, or don't create any anonymous inner class. Just means you can use the lambda expression for that interface. Means, for example, if in left side, if I am writing student and student s, then in right side there obviously we are going to write the new student. Means we can't write the student s is equal to new employee, right? Means by default this will be there, right? And the student interface going to have the single abstract method. So by default the anonymous inner class will have the definition for this method, right? Means the definition this anonymous inner class will have will have for this show info method, because there is only one method. So what Java 8 says, you can remove this boilerplate code, that is, yeah, you can remove it. Then I need to remove this also. Then you just need to add this lambda expression. Okay, that's it. Means what Java 8 says, Java 8 says that you can use the lambda expression for functional interface, right? So by default we are defined the data type of the parameter here. So why we need to define it here? It means you can remove it. If there is a single parameter, you can remove the brackets also. If there is single statement, you can remove the curly braces also. So this is same. So if I execute, this will give you the same result. Okay, so this is how we reduce the whole lot of codes in a single line. Okay, so if you okay, so if you are thinking like behind the scenes it is going to again create the anonymous inner class, then no, it is not going to create the anonymous inner class behind the scenes. Means if you are thinking that it is going to replace this line with the anonymous inner class, then you are wrong. So let me prove that. For example, consider, okay, let me run this program in Java, because in IntelliJ we cannot, means it doesn't show the class file which is created for the anonymous inner class. Okay, so okay, then I saved this file in sorry, first, okay, let me again go back to my anonymous inner class, and if here I write as student, okay, and if I saved this file in on my desktop inside the folder of example, and if I'm going, okay, let me open that folder also. Where is the example folder? Okay, here it is, example. Okay, so if I execute it using Java C compiler, that is, let me go inside that directory cd and then example. So if I execute this using Java C, then I have Java, okay, sorry, I think I missed that interface. Yeah, okay, if I execute this again, then you will get to know that there are three class files are created, that is one for the app, that is this one for the app, one for the student, and one for the anonymous inner class. This is the class file of anonymous inner class. Let me delete this all the class files, and I'll run this code again with anonymous with lambda expression, that is and name equal to system dot out dot println. Okay, if I again compile this program, then we'll get to know that there are only two class files. There is no class file for the anonymous inner class. Okay, so behind the scenes it is not going to create the anonymous inner class. Okay, I think we should go back to our main example. Okay, so this is how, means this is how we reduce the code using lambda expression. So let me take one more example. uh, Consider there is a list of integers, data is equal to new, sorry, arrays dot as list. It will have the data as 11, 12, 13, 14 and 15. Okay, okay, then if I want to print all the data which is present inside this list, then what I can use, I can use data dot for each, then here I can use the lambda expression. Okay, if I execute this program, this will print all the numbers. Okay, right? But here's the question is how this line came here, means how we reduce the whole lines of code in single line. So let me explain that thing. For example, if I go back to for each, then if you go back to the for each, then for each accept the object of consumer interface, right? So if I go to the means what is if you go back to the consumer, then you get to know this is a functional interface which has the single method, that is accept method. Okay, means for example, if I write here consumer, if I go to the definition of this interface, then here you will get to know that this is a functional interface, means this interface is going to have single abstract method, that is word accept. Okay, let me go to my own new file, my original file, that is app. So by default for each accept the object of consumer. So consider I created my class my consumer, which will implement the consumer interface. Because of my list is of integers, I need to write here integer. So by default there is only one method which we need to implement, is accept method. So what I'm going to write, I'm going to just write as integer. And if here I create the object of consumer of integer c is equal to new my consumer. Okay, then if here I pass the c, then this will give you the same result. Okay, but as we see in our early example, rather than creating the whole new class, what we can do, we can create the anonymous in our class, right? That is new consumer. So what if here I write as integer, this will also give the same result. Okay, but as we see in our early example that if it is a functional interface, then don't go for writing the whole new that boilerplate code. You can use the lambda expression. So I can remove this boilerplate code. Okay, by default data type is defined, so you don't need to define this here. I can remove this because there is single parameter, then because this contains the single statement, so I can remove this braces also. Okay, so rather than passing c, I can use this as it is, means rather than storing this in c variable and then passing, I can directly put it inside this, means I can directly pass it to the for each, right? And if I remove, rather than using integer as a variable, if I use the I, then you will get to know that these both lines are same. So this is how, means this is how we pass the lambda expression. The only rule for lambda expression is that you can create the lambda expressions for functional interface, means the interface which has a single abstract method. Okay, okay, uh, okay. So can I use, how much you use the lambda expression, that much you are going to remove the boilerplate code. Okay, so for example, consider if I want to print the double of all the even numbers, that is 10 is a even, so I'm going to print 20, 12 is a even, so I'm going to print 24, 14 is a even, I'm going to print 28. Okay, so there is a one method, I'm going to write one method, public static uh, means to what the end result we want is we are going to print the double of all the even numbers. Okay, all op, this will take the, so means I'm going to call all op is going to return nothing. This will accept the this array list, so I'm going to call this all op method and I'm going to pass this data. So what I need to do here, Okay, if I want to filter out the even numbers, that is if I want only even numbers, right? So the logic for even number is this, right? If mod to equal to 0 means it is an even number, and I want to print the double object, that is x into 2, and then I'm going to show this number. Okay, so what this will give me the result after running the program is 20, 24 and 28. Okay, so but now consider, now I want the multiple of even numbers, but in future if I want the multiple of the numbers which are multiple of 5, that is I want the double of numbers which are multiple of 5, that is 10 is multiple of 5, so I want the double of 10, that is 20, and then 15 is a multiple of 5, so I want the double of 15, that is 30. So I again need to go to the, so this is known as the, I mean this is the main logic, right? So we can't go again and here change the logic here. Yeah, here is a single line we can change, but there, if you consider the large program, this there is no single line, right? So what we can do here is we can create one interface class interface with name as condition, and this will have one method boolean test going to accept the integer element. Okay, then there is class with name as e1 which is going to implement condition interface. Then there is a class named as multiple of 5 which is going to implement this condition interface. Okay, then this both the class must implement this test method. So what I'm going to do here, in e1 I'm going to pass x mod 2 equal to 0, and in multiple of 5 I'm going to pass x mod 5 equal to 0. Okay, so what I'm going to do here is I'm going to just going to take the object of condition interface, condition C, and then here I'm just going to call the test method of condition object, that is, and I'm going to pass this element. So if I want the multi, that is double of one numbers, then I just need to pass the object of e1. So this will print the 20, 24 and 28. And if I want the multiple of if I want the double of multiple of 5, that is double of double value of the numbers which are multiple of 5, that is 10 and 15. Okay, so I need to pass the object of multiple of 5. This will give you the 20 and 30. Okay, 20 because multiple of double of 10 is 20 and double of 15 is 30, that's why it is 20 and 30. Okay, but as we discussed in our earlier example, that if you look at the close here, the condition is a functional interface, that is don't go for implementing this interface, you can just pass the lambda expression, right, rather than pass. Okay, I think I removed this code also, sorry. Okay, if one condition is a functional interface, so I don't need to write the classes which are going to implement this interface. Here what, if I want the even numbers, then I will pass the code for e1, that is x, and then yeah, that's it. This will print the multiple of even numbers. If I want the multiple of, that is double of numbers which are multiple of 5, then you just change the logic here. Yeah, that's it. Means I created the lambda expression for this functional interface. Okay, but the problem here is that, not the problem, but here we created the one interface, that is condition, but by default Java provides the so many functional interfaces which we can use. For example, there is one interface which Java provides known as predicate. If you go to the definition of predicate, the predicate is functional interface. The predicate interface has the method which has the name as the test. This method, if you look at the method, this is the same as which we have in our own interface. So rather than using our own interface, we can use the interface which is provided by the Java, right? So rather than going to use my interface, what I'm going to use the interface which is provided by Java, that is predicate because these are integers, so I need to pass here integers. Okay, let me change the object name also. So what you can do, as we see in the definition of predicate, that predicate also has the method known as test. Okay, so that's it. Yeah, this will also work fine. Okay, 20 and 30. Okay, so okay, for example, we use the function interface for testing the means for filtering out. So what we are exactly doing here, we are just mapping the value, that is we are mapping the double value to the itself, right? So what the Java also provides one more interface known as function interface, which accept the integer means let me complete, then I will explain. Okay, so function is also the functional interface. So this is the input to the function, means the function, the method which is present in the function takes the integer as a argument and will return the integer as a argument, because we are passing this this is the integer type, right? So this is going to be the input to the method which is present inside the function interface, and it is also returning the integer, right? So we are defining here as the integer. So what I can do, I can just define the that what I need to do. That's it. Here what you can just use this function dot apply and then x. Yeah. So this is the definition for the test method of predicate interface, and then this is the definition of apply method of function interface. Okay. So to print, we have one more interface as we saw in our earlier example, that is consumer interface, right? So consumer, which will take integer because we are printing integer consumer. Then what I will do here is I will just call consumer dot accept, then I'm going to pass x, and the logic, that is definition for this accept method, I'm going to pass here, that is x and s out x. So this will give you the same result, that is 20 and 30. So this is all about the lambda expressions. The just remember only one rule, that we can create the lambda expression only for the functional interface, and the functional interface means the interface which has the single abstract method. Okay, so thank you guys for watching this video. We're going to look the next feature of the Java in my next video, so thank you.